All right, hi everyone. I'm Alex Christensen from NASA JPL, and I'm going to be talking about upscaling some of our marsh models to the Louisiana landscape. This is work that we're doing with Robert Twilley and his PhD student Pradipta, as well as Andre, Mark, and several others from the Delta X team. So Tracy already introduced the Louisiana problem of land loss and the difference between sediment-rich and sediment-poor basins. So we'll just do a quick reminder. This is the Atchafalaya Basin, which is sediment-rich, versus the Terrebonne Basin, which is sediment-poor, and these are the study areas of the Delta X mission. If you're not familiar with Delta X, it's a NASA suborbital mission, which means that in 2021, we had 2 large field campaigns, which included collecting a lot of in situ data of soil, water, vegetation, as well as flying 3 different aircrafts that will eventually have something similar in space in satellite form. And then this project is wrapping up now, and we're in the process of building and validating some numerical models, which look at hydrodynamics, morphodynamics, and some carbon and marsh accretion. So again, as Tracy already highlighted, the process of marsh growth, we use a model called NUMAR 2.0. It is kind of a change to Newman, which is a mangrove model, but basically it has some basic soil formation. So it's a cohort study. It builds on top of itself each year. So this is meant as long-term accretion and soil formation, as well as carbon sequestration. So this animation kind of shows the processes that are included. So we have mineral deposition, organic deposition, as well as root development. If we summarize this into these pieces, this is what we're simulating with NUMAR, and these are the inputs that are required for this model. So obviously, most of these things are not measured when we do field work, and so a lot of this is extrapolation or best guess. And for the Delta X project, what Pradipta did was he ran this model or calibrated the NUMAR model for 6 field sites. And these 6 sites represent a salinity and a sediment gradient, but again, they're just 6 field sites, and we can't say necessarily that they represent the entire Atchafalaya and Terrebonne basins. These, if you're familiar with the CRIM sites, many of these are also CRIM stations, so we have a lot of additional information, but not necessarily everything we would need for NUMAR. So his master's thesis calibrated this model for these 6 sites and came up with accretion rates and carbon sequestration rates for those 6 sites, which are represented as, Atchafalaya, fresh, brackish, and saline, and this is the Terrebonne, fresh, brackish, and saline. So salinity and sediment gradients. So if we look at the carbon sequestration values, these kind of fall within the error bar that Tracy showed. So we see a lot of, especially in the salt marsh areas, we see a lot of variation here. And again, if we are trying to scale this to a larger landscape, we're taking these 6 values and applying them across a very large area. And whether or not that is valid is something we're still deciding. So I guess I've come to this workshop to get some feedback on how we use this model and how we can scale it to the landscape. Again, at JPL, we do a lot of remote sensing, so we're trying to see how we can scale these using remote sensing products and how we can find these model inputs across the landscape. So to do that, we've taken a first stab at running the NUMAR model across these 2 Louisiana basins. So one product that we're using from Delta X is the Avarice NG, which is a hyperspectral airborne instrument. We've derived above ground biomass from that. And so using some very basic relationships, we can turn above ground into below ground biomass using a root to shoot ratio. And then using a root attenuation coefficient, we can determine how much biomass is at the surface, which is one of the parameters that NUMAR requires, live fruit biomass at the surface. Another parameter that NUMAR needs is the inorganic matter loading rate. So in the field, this would be measured with feldspar marker horizons. For the landscape, we're using a Delph3D morphodynamic model. So this can be run for 1 year or many years, depending, and we can get the amount of deposition that occurs. Right now, this does not include any progradation or erosion, right? So that's a big thing that's missing from the model so far. And then basically everything else, all of these other parameters are applied kind of paint by numbers. So we take those field measurements and we apply them based on the salinity or sediment gradients. So these are those 6 sediment rich to sediment poor and brackish, saline, and fresh classes, and we apply the field measurements. So 6 data points get applied across the landscape. So again, this is maybe something we could take input from others here. So a first preliminary results of the NUMAR for the whole landscape. This is mean accretion rate. Again, this is a long-term simulation. So this is average mean accretion rate over, obviously, average accretion rate over time. A lot of people, when they see this, they wonder why there isn't more here. And a lot of that is just the limitation of the input data. So for example, when we use Delta X products, we don't have a lot of data in the subtidal area of Wax Lake Delta. That's why it doesn't look very active. We also, the model, the Del3D hydrodynamic morphodynamic model does not have progradation yet. And so we don't see any land extension out to the sea. And instead, people wonder why there is so much accretion here where we all know that land is lost. So these are things we're still looking into. And then to get at carbon sequestration, which is kind of why we're all here, these values, I guess, are again kind of within the error bar that we saw earlier. We see a lot of carbon sequestration in these highly saline marshes, and that has to do with mostly the amount of root biomass that we find from the field data. So this is where we stand right now. Again, I mentioned that I'm here to kind of get input from others and how we can best proceed. These are the things we're still specifically working on. So we all know that there's the CRIMS data set, and we're trying to incorporate that into this model so we can extend past our 6 data sets, the 6 data points. However, we don't necessarily have all the parameters we need from CRIMS. So we don't necessarily have root to shoot ratios at all the sites. There's only a limited number that have that. They may have been taken many years ago, so are those still relevant? We also don't have a good way of deriving organic loading rates. So for feldspar, that's how much of the stuff that's deposited on the surface is organic. We don't have feldspar everywhere, and when we do, we don't necessarily know what % is organic. And then the next big thing we're working on is to couple the NUMAR model with the Del3D hydrodynamic and morphodynamic models so that they feed back on each other. So the hope is to run the morphodynamic model for 20 years, see how much mineral deposition there is and progradation or erosion, and then run NUMAR on top of that, give the NUMAR output of organic accretion back to Del3D, and kind of build the mineral and organic pieces side by side to get 100 years to 2100. And then finally, as you might have noticed, some of the remote sensing data, because it's airborne, is very limited in scope. So it doesn't cover the whole Louisiana coast. It doesn't even cover all of Terrebonne necessarily. So we're trying to supplement this with some satellite data, specifically using Sentinel-2, which is multispectral, and Sentinel-1, which is a radar satellite. Finally, as the Delta X project wraps up, we have a lot of data that we really want people to use. So if this is something that would be interesting to you, you can find data and tutorials. Hopefully these still work. We have anything from field data to airborne data to modeling data, as well as tutorials on how to ingest those data products and use them yourself or incorporate them into your own projects. With that, I will